Hi, class. Sorry about that. I had to check my notes, make sure I was saying the correct thing here. And actually, I was not saying the correct thing. Um, so let me kind of go back over this problem with you. We're talking about problem A, and we're talking about figuring out what is the proportion of the curve that is between a positive 0.80 and a negative 0.80. What I was saying was what we're going to do that is we're going to first find out what is the value of the curve that represents this arrow here all the way out. And that was the body of the curve, which was at 0.7881. But then the other thing that we have to figure out is this boundary here. What is the value for the boundary there at that negative 0.80? And I'm saying that we're going to subtract whatever that proportion is from the body, from this 0.80. The amount that we're going to find is now going to be the tail, right? Because we're going to subtract the tail from this chunk right here. So when we go to do that, we're saying that we're looking up that 0.80, and it is right here, and we're going to use the tail amount. And so what we end up doing is subtracting this tail, which is that 0.2119. We're going to subtract that from the entire body, which is that 0.7881. And so that gives us a proportion of 0.7 or 0.5762. What does that mean? That means that from the positive 8 to the negative 8, there is 57.62% of the curve contained within that area. Right, and so then there's this 57.62 chance that you're going to pull a z value from that area. Okay, so let's go ahead and move on to question B and see what's going on there. Here again, there's the same logic in existence here. We're asking what's the probability that I'm going to find this area under the curve between these two spots, between a negative 0.50 and a positive 1. So if we think about that on our curve, we're talking about between this negative 0.50 and this positive 1. We're going to do the same thing that we did up here. We're going to first find what is the z-score for 1, and then what is the proportion in the body. Then we're going to find the z-score for this 0.50, and we're going to find what is the proportion for the tail, because we're going to subtract this from this. Okay, so when we do that, I won't go to the unit normal table to find this. Let's just say, so I went there, and I found at the z of 1, in the section in the body, there was this 0.8413. And then when I went to the z-score for 0.50, the section in the tail was this 0.3085. Let's take just a quick look just to make sure that that's what we got. Okay, so for a z of 1, the proportion in the body is that 0.8413. That's that proportion there. For the 0.50, the proportion in the tail is that 0.3085. Okay, so yeah, we got it right. Okay, so once we figure that out, we know that we have the subtraction problem then, right? This minus this. That gives us 0.5328. And what that means is that in that chunk of the curve, there is 53.28%, or 53.28% that we're going to find a z in that section. By the way, I don't think I noted this. This is how we're supposed to be writing the answer in the book, right? So what's the probability that I'm going to find this situation? Well, the probability is this. Okay, so let's move on to question C. For C, same idea. What's the probability that we're going to find some z between 0.20 and 1.5? Let's just note both of these are positive numbers. So the slice that we're talking about is going to be to the right of the mean line, and it's going to be this little chunk here. So same idea for that 1.50. We're finding what is in the body. But the other thing that you might note is that when we go to look up that 0.20, right, we were thinking, oh, we'll look for what's in the tail. But we're going to look for what's in the body with this as well. Why at 0.20 are we going to look for the amount that's in the body? Because when we think about what's still being cut off, that's still body amount, right? Remember, tail is just a small chunk of a curve. Here, we're still chopping off half the curve plus some. And so, for both of these z values, we're going to go look up their body amounts, and then it's going to be this z value body minus this z values body. And that's how we're going to get this 0.9332 minus the 0.793. Let's just take a look at that just to make sure. Okay, so 0.20 body is 0.5793. That's that right there. And then the 1.50's body is 0.9322. Right. And so we've got it. That gives us a subtraction problem, and the answer to that subtraction problem is 0.3539. So that's 35.39%. That's going to be in that little area. Okay, so now we can move on to D. D is kind of the same idea as C, but on the other side of the mean, right? So we have, what's the probability that I'm going to find a Z that's between negative 1.20 and negative 0.80. That's this chunk of the curve right here. Again, we're going to go find our proportions. And this time, what it looks like to me is that both proportions are going to be tails, right? So with this one, I'm saying that I'm going to go look in the tail because I'm looking for a smaller chunk of the overall curve. And for this one, it's going to be tail as well, right? So it's going to be basically this tail minus this tail. Okay, so then what I should find is for negative 0.80, it's going to be 0.2119. For 1.20, it's going to be 1151. Let's see if that's correct. Okay, so we'll do the 0.80 first. 0.80. Its tail amount is 0.2119. Yep. And so for the 1.2, its tail amount is 1151. Yeah. And so that gives us a subtraction problem where the difference is 0.0968. So what does that mean? That means that that chunk of the curve is 9.68 of the overall curve. Okay, so let's go ahead and move on to question number 11. Here, what we're seeing is, hope you're not getting disparaged because or getting disgruntled because you see a lot of work. But here we got question number 11. It says, find the z-score boundaries that separate a normal distribution as described in each of the following. Right, so then they say, oh, well, for A, find this these boundaries that separate a normal distribution at the middle, where you're separating the middle 30% from the 70% on the tails. Okay, sounds like a lot of work, but actually this is pretty quick and easy to solve. Let's take a look at A. Basically what they're saying here is just figure out what is in the middle 30%. What is your probability of being in the middle 30%? That's what we're saying here, right? Because if we are in the middle 30%, then we know what the other 70% is because we're talking about 100% of the curve. Okay, so if we're just trying to figure out what is the middle 30%, then what we could say is that when we draw the curve, we're thinking in terms of this being the middle of the curve. On one end of the middle is going to be 15%, right? So it's going to be from the mean line out this way is 15%, and then from the mean line out this way is 15%. So that being the case, we are seeing that we can use column D, right? There was A, B, C, D. We can use the proportion in column D to figure out what that middle percent is. Why D? Because D gives you the proportion from the mean line to some specific Z value, right? So it's perfect for what we're being asked to do here. Okay, so what we're going to do is we're first going to go find this percent in the unit normal table. This percent that resides in the D column, right? Or at least the proportion that's closest to that percent. The overall is 30. I'm just looking for 1/2 of that 30. That's 15, right? 15 is half of 30. So I'm going to go into my unit normal table. I'm looking in my D columns. I'm looking for something that's close to 15. And I see the closest thing that I have is this 0.1517 inside my D column. So from there, I can just scoot on over and look to see what is the Z value that corresponds to that. I'll say, oh, it's 0.39. Okay, so what that means then is my answer to this question is plus or minus 0.39, right? Remember the question was, find the Z-score boundaries that separate a normal distribution as described in each of the following. Well, normal distribution where I know where the middle 30% is, if one end of that 30% is right here and one end of that 30% is right there, because we're talking about 15% on each side of the mean, right? When we go to write it in terms of Z, we just say that we're going to have a positive 39 on that part of the boundary and then a negative 0.39 on that part of the boundary, right? So basically it's the same logic for the rest of the questions, right? So the middle 40% now. Okay, well, take that curve, put the 40% right in the middle. 1/2 of it is 20%. The other half of it is 20% as well. So then we're going to now then go look for our section D, right? What's the percent from the mean to some Z value? Okay, so in section D, I'm looking for 0.20. Or like at least something close to that. The book said it was 0.1985. So there's our 0.1985. Reason why we're settling on this is because this is the number that's closest to 20% in that section right there, right? From mean and Z. So what's the Z value that corresponds to that? 0.1985. That Z value is 0.52. So we're saying that we would put a positive 0.52 right there and then a negative 0.52 right there. And we'd write it this way. Okay, so question C then. C is saying, what about the middle 50%? Well, take the curve, put that middle 50% right in the middle. Half of it is going to be 25%. The other half is going to be 25%. So then we're talking about 25%. That's column D information. Let's go look for that 25% in our column Ds. The book said that there is no exact 0.25, so the closest to it is going to be 0.2486. And that is right here. Okay, so what's the Z value that corresponds to that 0.2486? Well, it's that 0.67, right? So positive 0.67 right there, and a negative 0.67 right there, or you can write it like that. Okay, so question D, same idea. What is the middle 60%? Put that 60% right smack in the middle. half of it is 30, the other half is 30, because then we are saying that we're looking for 30% in from our section D. We can find that somewhere in here. We don't find an exact 0.30, so the book says go with that 0.2995. What's the Z value that corresponds to that? It is 0.84. And so that's why we have 0.84 right there. Okay, so let's go ahead and move on to question number 13. Here this question is saying, a normal distribution has a mean of 30 and a standard deviation of 12. For each of the following scores, indicate whether the body is to the right or left of the score and find the proportion of the distribution located in the body, right? So we've got four scores that we're going to do this with. The first one is x equals 33. Maybe just to make sure that we understand what's going on with the question, let's write down what I think is the pertinent information, right? So one thing that's important is knowing they told us mu of 30 and standard deviation of 12. So when we envision the curve, right, when we think about what's going on here, they're saying that because we have a mu of 30, right, that 30 is going to be right in the middle of the curve. And also, because they have a standard deviation of 12, then when we go one standard deviation out this way, it's going to land on x value 42, right? 30 plus 12 is 42. And if we were to go out standard deviation this way, then the x value that one standard deviation would land on is an x value of 18, because it's 30 minus 12 equals 18. So with that, right, that gives us some ability then to think about where x equals 33 is on this curve. I don't think I actually needed to know that to really, well, I guess I could just see it from here, right? What I can see by just looking at this curve is, in answer to the first question, where's the body? Is it to the right or to the left of the score? What I can see here is that for that, there's our mean of 30. We're saying we're looking at this x value of 33, so it's going to be about right here, right? So if we throw up our vertical line, where's the body here? The body is that chunk of the curve, so the body is going to be to the left of our vertical line, right? And that's where I'm saying this right here. But then the other question they're asking is to find the proportion of the distribution located in the body. Okay, so what is the percent associated with that part of the curve? Notice that so far they've only told us what the x value is. To be able to find that percent, we need to know what is the z value that corresponds to that x of 33. How would we figure out what that z is? Oh, we use that z formula from chapter 5, right? We say our x of 33 is going to be subtracting that mu of 30, and that's going to be divided by your standard deviation of 12. That reduces to 3 over 12, which reduces to 0.25. So now we have a z value that we can go look up, that 0.25. When we do, remember the proportion that we're looking for is the proportion that's in the body. So when we go to our 0.25, there's our proportion in the body. It's this 0.5987. Okay, so let's go ahead and move on to question number B then. X equals 18. Same idea, right? Where is that 18 on the curve? Here we're saying it's right here. So if we have our mean line right there, and we're seeing that the 18 is right there, where's the body here? Well, the body, or the most of the curve, is right there, right? So the body is going to be to the right of that line that represents that x value. Okay, so we've answered that question. Now what is the proportion? Well, same thing. We have to first figure out what is the z for 18. We do that by running through the z equation. 18 minus 30 over 12 reduces to negative 12 over 12, which then reduces to a negative 1, right? So that's our value that we're going to go look up at the unit normal table. Remember that we're looking up the proportion that's in the body at z equals -1. There are no negative numbers on the table, so we're going to go to the positive one. The proportion of the body is that 0.8413, so that's what we're going to write as our proportion. Okay, so same idea, but with now x equals 24. With this one, let me just draw the curve real fast. Where's the 24 here? Right, so there's our mean of 30. 24 is less than 30, so our x value is going to be right here. Where's the body compared to this? Well, the body is, again, to the right of that vertical line. And so that's why I'm writing right here. Okay, so but now we got to figure out what's the proportion in the body. Here, remember we're saying our x 24 minus 30 over 12 reduces to a -6 because it was 24 minus 30 over 12. So now it's a -0.50. Remember that we're just looking for a positive 0.50 because it corresponds to the negative. We're finding the body in that spot. It's that 0.6915. And so that's what we're going to write down for ourselves. Okay, last question for number 13 is x equals 39. With this, first thing we'll do is draw that curve. Where is the 39? So remember the mean is 30. 39 is to the right. So then the body is going to be this way, right? It's going to be to the left of our vertical line. But then we want to find out what's the proportion there. First thing that we're going to do is figure out what's the z for our x of 39. So the equation is 39 minus 30 over 12 gives us 9 over 12. That reduces to 0.75. So we look at 0.75 z score, and we find the amount in the body there. It's at 0.7734, and so that's what we're going to write down as our answer. Okay, so that's problem number 13. I'm going to go ahead and move on now to our next problem 15. Here we're saying in 2014, the New York Yankees had a team batting average of 245, actually 0.245, but we will avoid the decimals. Of course, the batting average varies from game to game, but assuming the distribution of batting averages for 162 games is normal, with a standard deviation of 40 points, answer each of the following. Okay, first, I just want to make sense of what they're saying here, right? So we have a mean 245, and the distribution of batting averages for 162 games is normal with a standard deviation of 40. Okay, so these are the two bits of information that are important, what the standard deviation is and what the mean is. The reason why that's important is because it gives us information about what's going on with our curve. We know that 245 is in the middle, and then we're moving away in standard deviation 40x scores at a time, right? So your first standard deviation over here is 285 because it's 245 plus 40. On this side, it's 205 because it's 245 minus 40. Now remember, for standard deviation, all the numbers are positive. You have a negative number here when we're talking about z's. Okay, so from there, let's go and answer our two questions. First one is, if you randomly select one game from 2014, what is the probability that the team batting average was over 300? Okay, so what they're asking us to do, I didn't draw a curve. What they're asking us to do, right, is to have that curve, seeing that the mean is 245, and they're saying, but what about 300? And what would be the probability of finding something that's over 300? So it's going to be that section of the curve, right? More than 300. So let's just know we're being asked about tail section here. Okay, so with that, let's make sense of the question. Looks like what we need to do here is think of that 300 as a x value. What we want to do is find out the z value that goes under that x value. So then we can use that z value to figure out what's in the tail. Okay, so is that what I did? Let's take a look. Yep, that's what I did. Okay, so thought of that 300 as an x value. I subtracted the mean from it and then divided that by the standard deviation of 40. That reduces to 55 over 40, which reduces to 1.38. So then I went to the z value of 1.38, looked up what's in the tail section, and I'm finding that 0.838. Let's see if that's what I wrote. Right, so the tail section is 0.0838. Okay, so for question B, if you randomly select one game from 2014, what is the probability that the team batting average was under 200, right? So now this is our new X value. First, I guess we'll do the curve. They're saying the mean is 245, but we want something at 200. And what at 200, we want to know what's less than the 200. So, right, so what part of the curve is that? Again, that's the tail section of the curve. How are we going to figure that out? Again, we're going to think of 200 as an X. We're going to turn it into a Z. We're going to figure out what value goes at that Z value under that X. And then we're going to use that Z to figure out what's in the tail. Okay, so first things first, the Z-score equation. We have 200 minus 245 over 40. Reduces to negative 45 over 40, which then reduces to negative 1.13. So I go look up that 1.13 in my table. I find it right here. Remember I said that I'm looking in the tail. And so for the tail, I find that 0.1292. Is that what I wrote down? Yes, that's what I wrote down. That's what's in the tail. Okay, let's go ahead and take a look at question number 17. What's going on with that? To begin with, we have useful information. They're saying the distribution of scores on the SAT is approximately normal, with a mean of 500 and a standard deviation of 100 for the population of students who have taken the SAT. And then we've got these set of questions. First, let's just make sure we understand what's going on with our curve. Looks like I'm doing it one at a time. Let me just say on here. Okay, we have a curve. We're saying the mean is 500, and one standard deviation away from that, in this way, would be 600, and another standard deviation away this way would be 400. Okay, so given that, question A is asking, what proportion have SAT scores less than 400? Okay, looks like I need a curve for that, right? So what they're asking is, you have a mean of 500. They want to know what proportion of scores have less than 400, right? So you have your X value of 400. Less than would be that chunk of the curve. So the way that we're going to figure that out is we're going to turn that 400 into a Z value, and then we're going to see what is the tail section for the Z that corresponds to that. So first thing that we're doing is our Z equation. We're taking our X, we are subtracting it from our mean, and then dividing that by our standard deviation. It gives us negative 100 over 100, which reduces to a negative 1, right? So that's the Z that we're going to go look up. Not negative, but just positive. But we're going to look for what's the tail part of that. I'm seeing that it's 0.8413. See that it's less than... Oh, I'm sorry. Okay. I'm freaking myself out. I'm looking for what's in the tail, and it is 0.1587. I think I'm trying to finish this up a little too fast, so I'm going to slow down. Okay, but so now we got problem number B. What proportion have SAT scores greater than 650? To figure that out, first let's think about what's going on with the curve. Our mean is 500. They want to know greater than 650, right? So our X value is 650, and they want to know what's more than that. What's the probability that I'm going to get something in that part? What is that part? That's my tail again. So first thing I'm going to do well, let's remember what we want to do here is we want to take that x value of 650, turn it into a z value, right? What z value goes right there, so that we can use that z value to figure out what's in the tail. So how are we going to turn that 650 into a z? We're going to pop it into our z equation, where it's our x minus our mean over our standard deviation. That gives us 150 over 100, which further reduces to 1.5. And I'm just going to go look that up. 1.5 is right here. We're talking about the tail again, so 1.5 is 0.0668. Okay, now let's go ahead and move on to problem number C. Here it says, if the state college only accepts students from the top 40% of the SAT distribution, what is the minimum SAT score needed to be accepted? So the way that I drew that curve was like this. I don't know why I have that 20% there. Let me think about this for a second. Okay, so first, what there? Oh, shoot! I'm not looking at this. I'm looking at this. Okay. What is? We're talking about problem C. That's C. So what is the minimum SAT score needed to be in the highest 20% of the population? Right. So what's needed to be out here? What X do you have to get to be in the 20%? The thing that they're saying here is that they're not giving us an X value to look up. Instead, what they're saying is we're giving you some percent that you have to be at. And so what I did was I said, okay, I don't know what my X is, but I do know these other bits of information. I do know that, how did I figure out that? I'm gonna go look up that Z of 8.84. And yeah, okay. And I knew that I was going to look for what's in the tail, that's at 20%. So I went to my tail column and I looked for where is there 20%. And I found, oh, here's where there's 20%. There's 20% at a Z value of 0.84. So that's my Z that I already am working with. Just to make sure that you're getting this. What is the minimum SAT score needed to be in the highest 20% of the population? Right, 20% is the cutoff right there. Highest 20% is this section of the curve. What section of the curve is that? That's the tail. So what they're asking is, find a tail proportion that is 20%. What is that? That's a tail proportion that's 0.2005, right? Because that rounds to 20%. That rounds to 20%. So once you found that, then find the Z value for that. Why are you going to find that Z value? Because then you can use that Z value in your Z equation, right? You don't know what X is, but now once you know that 0.84, you know enough of the equation to solve the equation, right? You were already given that 500, that's the mean, and you were already given that 100, that's the standard deviation. So now what you're doing is you're solving for X. How are we going to solve for X here? Basically what I'm going to do is I'm seeing this as now an algebraic equation. I'm going to take that, I want to get that X alone by itself. The way I'm going to do it is I'm first going to move this 100 out of this part of the equation. How am I going to do it? The way I'm going to do it is I'm going to multiply it by this 0.84. So I should get rid of this decimal here, right? So I multiplied it by 100. When I did that, it made it now 84 equals X minus 500. So then from there, I still want to get rid of, I want to get this X alone. The way I'm going to do that is I'm going to add it on this side. It's going to cancel it on that side. And then I'm going to add that 500 to that 84, and that gives me 584 equals X. So what the answer to this question is if the question is, what is the minimum SAT score needed to be in the highest 20% of the population? Well, the answer is you have to have at least a 584 on the SAT to be in the top 20%. Ugh, okay, let's move on to now problem number 19. 19 says, a report in 2010 indicates that Americans between the ages of 8 and 18 spend an average of 7.5 hours per day using some sort of electronic device, such as smartphones, computers, or tablets. Assume that the distribution of times is normal with a standard deviation of 2.5 hours and find the following values. Okay, so in all this, the important information again is the mean and the standard deviation. First thing I want to do, right, is just make sure we have a sense of what's going on with those values. So we have a curve here, and we're saying 7.5 is the middle, 2.5 is our standard deviation. So one standard deviation higher than the mean is an x value of 10, right? And then two standard deviations higher than the mean is 12.5. Okay. The question that they're asking in question A is, what is the probability of selecting an individual who uses electronics devices more than 12 hours a day? Right. So basically, what is the probability that I'm going to find someone like right here at that 12? Right. So again, they're saying who uses it more than 12 hours a day. So we're finding that the probability of being in that chunk of the curve, that looks like tail. So to figure this out, we're going to take that 12 that they're talking about, and we're going to find what's the z that goes in that 12. Then we're going to use that z to find the area in the tail. So the way that we're doing it is 12 minus 7.5 over our standard deviation of 2.5. Reduces down to 1.80. Right, so this is our z that we're going to look up. Remember that we're looking for what's in the tail at that spot. So for 1.80, I'm going to the tail, and I'm seeing that I've got 0.0359. So what I should find then is that that's my proportion that's in that spot. How much of the tail is it? It is 3.59% of the tail, or of the curve. Okay, so that's our answer to question A. Let's look at question B. Saying, what proportion of 8 to 18-year-old Americans spend between 5 and 10 hours per day using electronic devices? In symbols, the way that they're writing it is, what's the probability that I'm going to find some x value that's greater than 5? Or what's the probability that 5 is going to be smaller than x, and x is going to be smaller than 10, right? So then I'm going to have these two boundaries. Or just sketch it on the curve. Here's my 5, here's my 10. What's the probability that I'm going to find some x value between those two? I think one thing I'm just noticing at this moment is that there are your two standard deviation units too, right? So one standard deviation unit above the mean is 10, and one below the mean is 5. That's interesting. Okay. But now what we're going to do is it looks like we have to find, again, like that boundary region that's right here. Let me just make sure I'm doing this right. Yeah, so what we're going to do is we're going to find the z that's right here and the z that's right there. What are we going to do? We're going to find the body for this z, and then we're going to find the tail for that z. Okay, and that we're going to subtract that tail from the body, and that's going to give us this. So, to start off with, 10's our upper boundary, so that's our x value. It's going to minus the 7.5 over the 2.5 gives us a z value of 1, right? But we already knew that. right? Because we saw that with our standard deviation units. We saw that that 10 is one standard deviation unit away from the mean. That 1 maps onto z-scores. So we already knew that we had a z of 1 because the standard deviation was 1. Let's see if we know what our z for that 5 is. I'm saying the z that we find for that 5 is going to be 1 because the standard deviation for that 5 is 1. Let's see if we get that with our equation. Yeah, we get that with our equation. Oh, but it's a negative 1 because it's a z, right? But it's going to 1 because, or negative 1 because it's 5 minus 7.5 over 2.5, which reduces to negative 2.5 over a positive 2.5, which gives us that negative 1. Okay, so now remember what we're doing is we're finding the body for this, and we're going to subtract the tail from it. So body at 1 is 0.8413. Basically, we're still working with 1 here. We're going to subtract that 0.1587. Let's see if that's what I did. Yeah, so that 0.8413 minus this 0.1587, and that's saying then that we get this 0.6826. That is the percent of the curve that's within those two boundaries. Okay, you know what? This is our last question here, just in case you're getting worried about time. So question number 21. Last question right here. A multiple choice test has 32 questions, each with 4 response choices. If a student is simply guessing at the answers, then we have these 2 questions. The first thing, let's just make sure we see what we have here. We have 32 questions. Each question can have 4 different responses. Okay, so like we're thinking of this is like our total right here. And this could be like our n, right? 4 potential responses that we can give. Okay, so what is the probability of guessing correctly for any individual question? Now remember that that's the probability that you're going to have some x over a total. We just said that the total is 32. So what would we think about this as the x? Well, I am thinking of it as 1 out of 4. And the reason I'm thinking about it as 1 out of 4 is because even though you've got all this, really what you have is the 4 responses per the 32 questions, right? So really your total is the 4 responses. Now of those 4 responses that you're going to give, 1 can be correct. So the probability is 1 out of 4 or 0.25. Right, for any individual question. For an individual question, you have a total of 4 responses that you can give. Only one of them can be right, so it's going to be 1 out of 4 or 25%. Okay, but now, on average, how many questions would a student answer correctly for the entire test? Now, for the entire test, that's where we're saying our total is 32. And with that, we are saying 32. I gotta look this up. Okay. So actually what we're saying is 32 divided by 4 is 8. I'm gonna have to think about this. I don't see why we're getting this. But I'll also say, for C, I also don't get why they're saying, so this is the answer they give in the book for C. First, let's go over the question. For C, they're asking, what is the probability that a student would get more than 12 answers correct simply by guessing? When I see this question, what I see is 1, they're talking about 12 answers, and 12 is your X. Right, and so I'm looking to get some kind of Z-score from what they're saying here. They've told us what the average is. The average was what they gave us in question B. On average, how many questions would a student answer correctly for the entire test? I still don't see why they're saying it this way, but they're saying the average is 8. So 8's going to go right there. What they're not telling us is what our standard deviation is, right? So I don't see that they've given us enough information here to really solve the equation. But in the back of the book, they're saying this is what your z equation is going to be. First, that's not just going to be 12, but it's going to be 12.5. I guess I see that because they're saying more than 12 answers. They're saying, okay, the average is 8. Okay, I'll give you that. But what I don't see is how they're getting the standard deviation of 2.45. In any case, they're saying that the probability of getting it is this 0.329 or 3.29%. I'm going to stop here at this point because the questions after this get a little complicated, and I don't think that I really want to go that deep. I mean, you're already seeing that I'm having trouble explaining the stuff as it is. And really, I think that all you need to know to do well in the chapters moving forward are the answers to the questions that we've already answered, right? Using the logic of knowing how mu and standard deviation are related to where their places on the curve. And then from there, knowing that you get x values, or you use x values to get z values, and z values help you figure out where proportions under the curve are. As long as you are able to figure that stuff out, you should be fine moving forward. So I'm going to go ahead and stop here. Thank you, and I look forward to seeing you in the next chapter.